This is the last of the practice problems for applications. These problems are going to involve half-life, which is exponential decay, and that occurs when a is less than 1. So here's an example. We want to solve this problem, and then after we solve it, do the math. I want to show you what that 0.91 means. So we want to solve 0.91 to the t equals 1/2, or 0.5. Okay, so I take logs of both sides. Bring the t down. So I have t natural log 0.91 equals natural log 0.5. Divide both sides by natural log 0.91. Okay, that gets canceled out. And then my answer is going to be 7.35 when I round. Okay, now that's an example. That means the half-life is 7.35. So let's say that t is years. That would be 7.35 years. It could be days, it could be hours, it could be something else, or infection cycles. Okay, so what does A equal 0.91 mean? What it means is there's a 9% decrease every year. So it's like anti-interest. How do I know that? Well, I know that 0.9, here let me do it this way, 1 minus 9%, that would mean a 9% decrease. It's going to be 1 minus 0.09, and that's going to be 0.91. So that's how you interpret it. You subtract whatever number this is, you subtract it from 1, and that's your decrease rate per year or per time unit. Okay, so here's some practice problems. I'm going to have a third one. So this is another infection one, and they call it R. That's the infection rate as we saw, so that's really the A in these problems. Okay, we're going to figure out what that means. As you can tell, that's going to mean a 29% decrease. Okay, we'll go over that. Okay, so I want to find out if that's what the R is, if each person is infecting 0.71 people, when can we expect the number of infections to be cut in half? So what I'm going to do is I'm going to solve this problem. It's the rate, 0.71, to the t is equal to 0.5. Okay. Again, this is just like the problems before, except instead of a 2 here, it's a 1/2. Instead of this being greater than 1, it's less than 1. Okay. So I take logs of both sides. Okay. Bring down the t as before. So I get t natural log 0.71 equals natural log 0.5. Divide both sides by log 71. And that's my t. And then I do the calculations for this, and I got 2.02 cycles. Remember, a cycle is about 5 days, so we're going to round it to 5. So the answer would be 2.02 times 5 days, which is 10.1 days. So if we can get that infection rate down below 1, cases decrease. This 0.71 is what Iowa was on May 1st. That's what the R was. So the cases were really starting to fall. Okay. And so that would mean if we had kept as we were going then the rate would have been, we would have cut down the number of cases in half. And that started to happen for a while, but then it started to go back up again. So anyway, that's what that R is. Okay, so when you hear people talk about getting the R less than 1, now you know why. Okay, so again, that number, I put the number in here just for context. It wasn't necessary. I did the same thing here. There are 14,000 people in the town. I'm just doing that to give you a size of the town. And I'm asking you, that population in a small town is declining at a rate of 4% per year. There are currently 14,872 people in the town. How long will it be before the population of the town is cut in half? And again, we're going to solve that. The decrease is 4%, subtract it from 1. So we'll start with that. So A is equal to 1 minus 4%. That's going to be equal to 1 minus 0.04, which is 0.96. So we need to solve 0.96 to the t is equal to 1/2 or 0.5. Okay. Again, this number, we know when it's cut in half, it's going to be 1/2 of that. So we don't need it here. We just know that we're cutting it in half. We saw a couple of examples of that. So I'm going to take logs of both sides. Use the power rule to bring the t down. Divide both sides by natural log of 0.96. And my answer, this cancels. So t is equal to natural log of 5, natural log of 0.96. And the answer that I got was 16.98 years, really 980 when I rounded to 3 places. And so that means the population would be equal to, in 16.9 years, the population is 1/2 14,872, and that's going to be equal to 7,436 people. So that's what the population was, that's how many years it takes. Okay, so I'm going to give you a bonus. I'm going to do one more problem. And this bonus problem is going to be something I think there are some potential pharmacy students in here. So what I'm going to do is, it's going to be about half-life of a medicine. And I'll talk more about what half-life is when I'm done. So here's the problem. Oops, I need to sort of refocus my phone. There we go. Okay, whoops. Okay, phone's getting tired, so we all are. Okay. A certain medicine leaves your body, so your body metabolizes it at a rate of 10% per hour. What is the half-life? In other words, when is it cut in half? So when is only half the medicine remaining? Okay, so again, we know how to figure that out. A is going to be 1 minus 10%. It's going to be 1 minus 0.1, which is going to be 0.9. So we need to solve 0.9 to the t equaling 0.5, 1/2. I'll put parentheses around. Okay. So we take logs of both sides. Should be getting really good at this. Bring the t down. Divide both sides by the natural log of 0.9. And that's my t. I use my calculator, and what I got was 6.579 hours. Now, people that compute doses of a medicine, they use the half-life. And they use this to figure out how they can get the concentration of a medicine that's in your body, at the optimal levels. And so you might see problems like this before. So anytime you have a half-life and you know the rate, you just 1 minus the rate, that gives you your A. Solve A to the t equaling 1/2. Okay, hopefully this was helpful, and thank you very much.